How's it going, everyone? Welcome to another video on the NeetCode, the problem solutions, where the end goal of this series of videos and from this is that we are now able to develop the sense when it comes to develop applications using computer science tools. So for example, like data structure, algorithm, and techniques as a way to understand what are the problems they solve, data structure and algorithm, as well as the techniques, and when can we use them. So this is part of the fundamentals of the computer science, and I think this is something very, very important to put a practice. And here we're gonna take a look at the NeetCode, which is made by Nadeep Singh. I don't know why he put that, but Nadeep Singh is a software engineer that previously worked at Capital One, and he was an intern at Google, and he also worked at Amazon for 2 months. But most of the time, his experience is based on that. And if you want to get into these fan companies, this is now the roadmap that he created as a way to make sense of how you can use all of these tools that I mentioned before. So the goal of this is not only to get into this fan company, right? The point of this is to understand what are the problems that this particular tools actually solve. And if you want, and in my case, if I want to now go out to a fan application, or if you want to go into a fan interview, that is something great for you. But the idea here is to understand these fundamentals concepts, because if you're going to provide this service, it is crucial that you understand the fundamentals and then how you can now provide value to a small or mid business. So this is where now my target it is, especially is that, yeah, I'm not going to compete again, or I'm not going to be one of these top 1% engineers. All right, but what I'm gonna do is to now getting closer to them by understanding is what is the problem that they solve and how they can do that. So wow, today has been a very it's getting warmer here, you know. It's getting warmer here. Right now I'm in Argentina, Buenos Aires. So we are on October. So we are getting to the summer times. So, all right. So the methodology here is that, well, we're first gonna dedicate 45 minutes daily to make a quick recap of what we have learned so far, and then read the problem, understand the problems, and hang how you can come up with some solution. At least let's gonna dedicate 20 minutes to that. And if we couldn't solve that, then let's gonna take a look at the solution, right? Because the whole point of this is that make the connections needed in your understanding when it comes to actually solve this kind of problem. So I am excited, by the way. Oh my God. Yeah, I am. Let's get into this. Okay, so this quick recap of what we have learned so far. If we take a look at this roadmap, and I think he actually improved that vastly. Exactly, now it expands that. So we started first with arrays and hashings. This is all about to be able to solve this kind of problems, right? Lead code problems. So we started first with this. This is 100 algorithm. Yes, exactly. This is with the 100 algorithm here. This is also something interesting as a way to understand is the algorithm and data structure for beginners, and then some advanced algorithm, system beginning for roadmap, object design, system design and view, and then full stack development. So yeah, this is something that he provides, and I get it why. You actually, this is you have to pay for this. And which is good, because what is worth something that is worthwhile, usually you have to pay for it. Not always, but you're gonna get the most. When you pay for something, you expect value from that. And if the value that you are getting from that is not there, then you're going to move on. So that's the dynamic here. So in any case, we're starting here with the arrays, okay? And how we can start working with simple arrays, with how can we check for duplicates elements, which is pretty straightforward. How you can validate an anagram, which is this works that reads backward and that when you read that backwards is the same. Okay, example of that is Anna, the name Anna. So we also use how can we use now string, how can transform that into a string and check that by sorting all of these elements in the string and doing now a comparison with that. So because at the end of the day, all of this string is now using a Unicode or UTF-8 or 16, which is a code unit table that now map is a symbol with a value, and particularly in the Unicode is a hexadecimal value, as a way to now have this easy way to map these symbols. And when you use now strings and numbers, all right, they have a particular order of how you can do it. So the two sum here, it was more like, hey, how can we now make sure that these two numbers, all right, actually are in these collections. So here we look at some tricky thing, especially as a way to look at the complement of another number. Okay, so as we iterate through these collections, we're going to store that using a hash. The key, yeah, I'm not going to dive too much into that, but the TLDR of this is that we're going to use a hash. We're going to use the collection, this string, this numbers collections, a collection of numbers, all right? And as we iterate through that, we're going to now store that in our hash, in our table, right, as a key. And if we already have that, and if when we check the difference with those numbers, and if that number actually match with one of the elements that we already visited, then we're going to now return that and stop the execution. So this is as a way to develop this basic notion of how you can work with arrays and hashings to solve specific problems. So most of the time, the problems that hashing solve with array is that if you need to count elements, if you need to group elements, or if you if you need to count, or if you need to group element most of the time. I think there was another one. Wait, what? Didn't write that? Okay, that's wrong from myself. Okay, that was not wise from my side. No, that was not wise from my side. Yeah, that was definitely not wise from my side. I also have now a doc here, which is a NeetCode, but not is in. Let me actually check that. The NeetCode. NeetCode, that's right. And then you got it. All right. Interesting that I don't have that. Let me actually put here is this. Let me actually add this resource. Okay. I prefer to put this here. Right. This is the resource for what? French toast. Oh, he's here. That's right. Okay, resource. So yeah, here we are now summarizing is that, right? So for example, with arrays and stack, right? Use hash to identify items in a collection. Use set to uniquely identify items in a collections. But the whole point of this is to what are the things that we can get out of this, okay? And how we're starting to develop a sense where we need to actually is use this particular data structure to solve particular problems. So anytime we need to count elements or group elements, hash and arrays are a good combo, which is what we have actually solved this with group anagrams. This top k frequent element, this is something very interesting because this is also something that we vastly use a lot when you want to know, when you want to search for some things in the database, or when you want to in your daily life know what are the most frequent places that I visit, what are the most frequent brands of food that I eat in. Chipotle is one of them, or if you go to 7-Eleven. So the idea here is, this is something that the US audience will get it, and also worthwhile, is that how many times, if you own a motorcycle, you want to know how many times you actually recharge, okay, your bike, because you want to keep track of that expense. So this is a good example of it. And now here using is like, because here we want to get is giving us this collection of values, all right? And I want to make a quick recap there, right? So if we by having this collection of value, which is numbers, all right, that they can represent anything, right? It can represent is how many times, or how many days, how many times per day you go to the gas station, or a week, you know. So this collection of values that you have here, you want to know is the most frequent k elements here. So one way to solve this is by saying, all right, now that I have these collections, okay, and I want to know is the most frequent, okay, so by getting this array and now group those elements, or count, all right, count those elements using a hash, where now in this hash you already iterate through all of these elements, you already have that, okay, in this table. Now that you have this, you want to create now an array with the same length, all right, that the input, where each one of those index will represent is the frequency of those elements. So what you're gonna do is that, because you have now in a hash that as the key contains a value, and the value is the frequency, you're gonna use that as a way to now indicate in this array with the same size, this is the value that we want to do. So this is exactly what we did here. Perhaps it's quite abstract here, but again, I don't want to dive too much. The whole point of this is just to be able to describe this, and I know that might be sounds boring to you. It's like, yeah, good for you, Paul, but what about the thing that we're gonna do? So yeah, you're right. But yeah, I just want to describe briefly what are the series of steps, the sequence of things that we are going to do as a way to now work with this, to solve this particular problem, to solve the most k-frequent elements. You got a collections, and you want to count is the number of occurrence here in this hash map. Then you create a new array. When this new array will represent, and the key word here is representation, because that's what software engineers live live in a world of abstractions and representations. Sometimes can be a hell, but this array will represent is the occurrence of those frequent elements. All right. Now, once you add all of them, all right, it is time for us to sort them. So now this array has a convenient method in JavaScript where we can now sort that by values and an ascending or descending order. In our case, we want to know is the most frequent elements. We ascend them into we sort them into descending order. You want to have the most frequent to the lowest, okay? And then you're gonna get is the most elements that you want, the k most elements here. You're gonna slice that and return that as it is. So this particular process of describing each one of those sentences, right, or this sequence of element is something that a lot of companies are looking for, not only for companies but also for yourself, because now you have a deep understanding of what the thing is doing. You can, is most of the time, save you time of doing things that are not relevant and provide the outcomes for that. So, okay, the top k frequency actually was a very interesting, completely mixed. It was a mind blowing, bro. Similar to the encode and decode string. This is to see how now you can work with the strings, and when it comes to add some specific data or read data from a string, you can do that. In other words, giving a particular we need to look at the external because we couldn't able to solve this. We just only solve this here, right? Now in JavaScript, what is this? No, I didn't put this thing here. Okay, they define this as a class. Okay, anyway, no, yeah, I remember. So the idea here is that they want to implement is an encode and decode. All right, so when we encode this series of data or string or character, when we decode that, we want to get the same output. So the thing here is that we are going in this collection, instead of number is now strings, we're going to insert some information, some piece of data that are now telling us what is the length of this word that we are encoding, okay? And some separators, so we can actually identify them. So by creating now this string, this format, where we say, hey, the first elements that we're going to add here, it will now represent is the length of that, the length here. The first element that we're going to store is represent the length, followed by the separator, because we want to know is when this end and start, okay? And then put the rest of information. And now repeat this sequence. So figuring out the length of that number you want to encode, figuring out the length of that word you want to encode, followed by a separator and the string. So the whole point of this is that you're starting to develop a sense, especially when you are writing your applications or your whether it's front-end code, back-end code, whatever code it is, but you're starting to develop is a sense of how now you're going to create sequence of process. A good example of this is the browser. So what you have now is ask yourself how the browser transforms its HTML, CSS, and JavaScript into pixel on the screen. It has a particular phase where they do something specific and do it well, right? So you have now the DOM, the CSS object model, and then the render tree, which is merge these two pieces of information, and then the reflow phase as a way to now calculate is all of the positions and the geometry of these elements on the screen, the HTML element as well as the CSS, right? And once that it's done, all right, let me now paint that, which is going to store that paints in memory, and then compose it. So how all of these different paints are going to look like on the screen. The idea is this. So I think this is something very powerful, very interesting, not only to solve all of this kind of code, right? It is important, it is interesting to solve this kind of thing, but it's to develop that sense needed when you need to actually solve a problem in piece that using is a divide and conquer, or see how you can now create sequence of data and how effective is that to solve a particular problem. I think this is something quite hard, especially if you are not into solving problems. That's one of the reasons why software engineering actually is a sought after it's a sought after role, all right? But those who now understand that deeply, right? Those who actually really want to do that, and I think this is beautiful, and quite it's also challenging, and slowly but developing you're starting to solve very interesting problems on an industry, and then you can now provide your knowledge to others. So in any case, this is in code. Okay, and then we talk about the decode. So once you have now this huge string, which this format, you want to know how to extract that data from that. So here, because we follow is this sequence of way of how can we now encode that, then we're going to actually define is the sequence of decode that. In other words, is extract information for that. So hey, because the first character actually representing is the length, and the follow is the separator. From there, we started to count that, okay, get that element, and append that to an array, right? Let's gonna put this element here, right? And do the same. So as you read that, that's very, very interesting. That's very, very interesting. Yeah, that's a very, very interesting here. And then you started to see some patterns that happen when you want to actually move across collections of values, which is the next topic on this, right? So for example, product and array itself invalid Sudoku. So I'm not gonna dive deep. It's just more like a mathematical sense. Invalid Sudoku, this is a way of how you can now work with matrix, a computer mathematical problem. And let's go to actually solve this, because I think we have let that problem unsolved for too long. And now it's time to put up practice that what you preach, bro. Now it's time to put up practice what you preach. Okay, let me get rid of this, okay, and understand this particular problem. So giving an unsorted array of integer nums, okay, giving an unsorted array of integer nums, return the length of the longest consecutive element sequence. Okay. Okay. Return the length of the longest consecutive element sequence in these inputs. So you must write an algorithm that runs in O (n) time. So what does it mean? You say, hey, we got these collections, all right? And a sequence, the meaning of sequence is that all numbers, so if we put this like this, 1, 2, 3, in this case, let's going to use now this particular example, right? So a sequence is that numbers that are next to another, right? This is the definition of sequence. So we want to know if we pass through this, we say, hey, the longest sequence, or as a way to first identify the sequence, we need to identify the sequence 1, 2, and 3, all right? And the other is 4, and then we have another sequence is 100, and then another sequence is 200. So the longest sequence here is 4, right? Okay, good. Exactly. The longest sequence elements here is 1, 2, 3, 4. Therefore, it is length 4. If we go to the next exercise, which is, hey, what are the sequence here? 1. Is there 2? No. No. Is there 2? Yes. So here what we're doing is now doing in the human way possible, okay? And then we're going to translate that. So hey, we say, since we already have this sequence, okay, 0, 3, 7, 2, 5, 8, 4, 6, 0, 1. All right, since we already have this sequence, we want to do is this. We want to get is 1, 2, 3. There is a 4. That's right. There is a 5. All right. There is a 6. All right. There is even 0, bro. My bad. So 0. There is duplicates. Okay. We need to handle duplication here. I was going to actually write it down here. So use cases or notes, notes is that handling duplicates. Okay, I'm gonna put this here. Notes here. Okay, so we start with 0, and then 2 if there are 2, and then 3 if there are 3, and then 4 if there are 4, and then 5, and then 6, and if there is 7 in our case that is. If there is 8 it is. And we don't have any numbers here. But we have a duplicate here. And we also have 1. So the sequence is this. So the sequence is this. So how can we actually sort this? So how can we now say, hey, because the longest sequence here, in this case is 3, 6, and 9, okay? How can we actually tell the computer to help us here to figuring out what is the longest sequence on an unsorted array, okay? So the easiest way to do this is by sorting that, right? So if we use a sorter, we use a sort, big O notation. Thanks for this cheat sheet here. Okay, so if we use a sort, depending on the implementation of the sort, in this case sort methods in JavaScript, MDN, Mozilla, it says that it says that it does in place. Okay, the time and space complexity of sort cannot be guaranteed as it depends on the implementation. So that's why fucked up. Interesting. Okay, so you can, but by default, by default, depend of the algorithm that they're using, if it is merge sort or team sort, okay, this will be the performance in the worst case scenario, right? So because we want to now run, this is one of the constraints here. This is one of the constraints here. Okay, I'm going to define here the constraint. Constraint. Make it that algorithm linear time. Constraints. Okay. Make the algorithm linear time. So sorting that won't be possible. You know, it's like, good, take care. All right, no problem. So what we can do here, if we're using now a hash or a set to store those sequence, okay? So now what we can do is to store those sequence in a hash, all right? So because sets, after all, it works as this key value pair, say sets here. Set object lets you store unique values of any type, whether primitive values or object reference, okay? Like this. The way how now this actually works is by doing this. So new sets. It's a set objects are collections of values. A value in the set may only occur once. It is unique in the set collections, and you can iterate through the elements of the set in insertion order. So what we can do here, okay, is by having is a set where it's going to store all of this sequence, we avoid the duplication, okay, and we need to find a way, all right, and we need to find a way to in our hash store that index. Why this is important? So here we solve the duplication problem here, right, with set. So now we want us to have an object that has an ID key, okay, where you say, well, this is the key, this is now the call. This will represent is the sequence. We say sequence 1, right? And this will have now a new set. Okay, say, hey, this will be a set. Say a set, right? It will be a set, all right? And then you have now a sequence 2, right? You got another set here, and you get the idea, right? We're gonna have as much sequence as we need here. The thing here is that we need to define is what is a sequence. So a sequence, all right, is any number whose next value is present. Okay. So in other words, a sequence is to say, hey, this say, hey, is this number, all right? Is this number R in the is this okay? Okay. Okay. So is this number okay? Okay. Okay. Is this number value? So as we okay. So So one way to solve this is by having this, right? So the thing here is that we're gonna have is all of this sequence and all of these sets. So far so good, right? And if we want to actually now access to the graders in an object, it'll be quite difficult to access through, okay? Yeah, it'll be quite difficult to access through. So what we can do, yeah, so what we can do, this is also part of the design. What we can do is to have now an array of sets. This is another solution. So where each one of those index will represent is the where each one of these index can represent is our sequence. Okay, so if we are going to now put all of this sequence, unique sequence, right, in this array, we want to know is what is the longest here. So one way to do that is that as we add in elements here, we can update the okay. It's gonna make things simple. It's gonna make things simple. So as we add sets here, okay, one way to do that is by adding these sets, okay, and check and the condition of a sequence is that if this element is this element, okay, let's gonna simplify this. I don't want to get rid of it. So we solve this particular problem, all right? This is unique sequence, all right? For example, what we can do here is as we iterate through all of these elements, right? So in this case, this. So as we iterate through all of these elements, we want to know is to somehow, okay, store the next element, or in other words, it's like somehow have an array where we can go into adding all of this sequence to this. So for example, hey, 0, it'll be initially, okay, and then if we now add this, okay, the next element will be is 3, all right. What happened here is that, hey, is 0 and 3 next to each other, okay? No? All right. So they, all right, move on. Next, 7, okay? 7. So 7 is next to we need to define it here. What is a sequence? This is the problem. We need to define it. What is a sequence? It's an element that is on the right. Okay, what is the most rightest elements there? So 0, no. 0 and 3, they are the next one. No, and we can check that by using it as a plus. But the idea here is that, hey, the sequence is going to be defined what is next here. So 3 is the following number of 0. No. All right. So 3, or in this case, yeah, exactly. We need to check it for the right elements. You say, hey, is 3 the next of 0? No. We're going to append that, right? hey, is 7 the next of 3? No. Okay. Hey, is 2 the next element of 7? No. Hey, is 5 the next element of 7? No. Hey, is 8 the next element of 5? No. Hey, is 4 the next element of 8? No. Hey, is 6? You get the idea. 0, no. And 1, yes. In this case, it is. So, if this is the case, okay, so we go now to add these elements to this. All right. This is just one pass. All right. This is just one pass. That's quite interesting. That's quite interesting. That's very, very interesting. Okay. So now, here in this result, okay, in this result array, all right, in this result array that we have here, we are now this sorted. We're starting to now put in this new state of this. So what can we do here? We can now iterate again to the result. Okay. Exactly. Iterate again through the result, and then ask the same questions. 0 is the next element to 3. No. If we do this, if we ask the next element to this, no, it is not. No, it is not. No, it is not. No, it is not. 6, no, it is not. In 1, no, the actual sequence actually is not that productive. So this doesn't actually give us too much outcomes. So we can try another alternative here by saying is that by having is a map here, okay, where we can now is okay, another thing that we can do is this. Another thing that we can do is this. Is now using an array, okay, to sort this. Right? How are you gonna do it? Because at the end of the day, this array is fixed. It's something that we provide. So one way to actually sort this, because if we sort these elements, it'll be good. Once we iterate through all of this, so what we're gonna do is to say, hey, the value of that index is that. So the first time is 0, and the next time we are going to check that, and we're gonna put that into the position of 3. 1, 2, 0, 1, 2, and 3. Okay. The next iteration on this element here is, well, 2. So I'm going to put that now value here. The next iteration here is, 3, sorry, my bad. The next iteration is 3, all right. The next iteration here is 7, 4, 5, 6, 7, okay. The next one is 2. When we are now here evaluating 5, is say, hey, let's go to 5 and put it here. And when we have now 8, let's gonna say, hey, go to 8, all right. And when it comes to 4, let's say, hey, let's going to populate now this with the 4. All right. And then you're going to check if the 6, all right, if it's 6, all right, then you're gonna check if 0. So if there is already a value here, okay, so what you're gonna is just update that value, so no problem. That's right, handling duplicate by updating such value, okay. And then we have now is 1. We got now 1. So far in linear time, we were able to sort this array, which is great. All right. So now with these things already sorted, okay. Okay. So now with this thing already sorted, we can actually check for the next element, all right, which is in this case it say, hey, is this element here next to each other? Okay, so we can now iterate, we can now right now, okay, that slowly makes sense. So we can now do this by using now a set as a way to get all of these unique values. All right, this particular set that allows to store all of these elements one by one next to each other. 0, 1, 2, 3, 4, 5, 6, 7. We want to now iterate through this and ask the question. Okay, and ask the question, hey, is 0 okay? That's one of the reasons why it's important here to create a pseudocode. So first, yeah, it's gonna create here pseudocode. So first, let's go to sort the array input by iterating through each one of them and populate its value and populate a new array with value and populate a new array where their values will be the index, where their values will be stored in the index position. So far so good, okay, which is exactly what we did here. Good. Next, now that we already have that sorted in linear time, so we are actually making this quite interesting. All right, the next thing is how we can define a sequence. So we can define a sequence. So we define a sequence as the existence of the next number. Okay, so how do we do? What it doesn't mean is that, hey, is this number actually have that the next one? Okay, that participate into a sequence. Okay, so we define a sequence as the existing of the next number. Exactly. So here what we're gonna do is to iterate. Okay, if we're just going to sort the array by iterating, through each one of them. Iterate through the sorted array. Okay, so iterate through the sorted array, and we're going to now starting to counting is this sequence. Okay. All right. Okay, so how can we now count sequence here? We can use is now a hash. We can use a hash for that, or a set. Okay, because I have a mental model of the hash, which is slightly different from the set. Okay. All right. So iterate through the sorted array, and as we iterate through that, we want is to count to add to the hash or add to the set. All right. Add to this unique collections here. But once we do that, we actually remove any duplicate elements. So far so good. And then we're going to sort the array. Okay? So iterate through the sorted array, where now we're going to see if the next element exists, right? If the next element exists, well, we are guaranteed that this is a sequence. What are the things that we need to return? Return the length of the longest sequence elements here. Okay, so we can have now is this. So as we iterate through this, we're going to ask if the next element on this sorted array is a sequence. Okay, if it is, then let's go to okay. So if the next element is going to start 0, okay. So if the next element, right? If the next element here, so if the next element is 1, okay, we want to add that to a data structure as a way to count that element, right? As a way to count that element. And we're going to do this for all of these elements. Hey, is it exactly? Hey, let's go into now counting is this for sequence elements. Okay, for subsequent elements, there is no problem. There's no trouble here, right? For subsequent elements, there is no trouble here. This actually will work as expected. But for this, all right. But for this, but for this, and again, the thing here of how we can sort this is doing the same. Is say, hey, at the position 100, all right, we're going to have the number 100. And at the position 4, we're going to have is the number 4, right? And in the position 200, we're going to have that. And at the position 1, we're going to store that. And at the position 3, we're going to store that. And at the position 2, we're going to store that. So now that we already have this sorted array, okay, with the length of the same as the size here, okay, we do that in linear time. We want to now check is the sequence of this, okay, by saying is, hey, by saying is that, hey, 1 has a next element is a sequence of that. 2, I'm going to add that to the set here, okay, which is 1 and 2, right? The next iteration we ask is, hey, 2 is a right element of this, okay? Yes, so 2 is the right element of that, so let's going to update our set, okay? 1, 2, 3. Hey, is now 3. We're just going to start by checking is the next element. Exactly, by checking is the next elements to that. Hey, 3 is 4 the next elements in the sequence. If it is, okay, add that to a set. 1, 2, 3, 4. All right. And if it's in this case, hey, 4 is the next element a sequence. No, it's not. You're going to create another set for that, which means is creating is another set. 100. And the same for this next element. Hey, 100 is 200 a sequence? No, you're gonna create now another set for that. So once we create this, all right, so we have now this sorted like this. You can say, hey, this set is in an array. Yeah, this is one set. All right, this is another sequence here. Yep, this is another sequence, and this is another sequence. Okay. Then you will like is to iterate through all of this, and then verify that. Do we need to actually iterate through that, or is there a better way to do that? Right? Okay, so another way to do this, all right, is that as we update our sets here, we want is to now as we update our state, we want is to actually because if you store this on a hash here, all right, so anytime we update this particular set, all right, what we can do is to update the index here, where this index will represent is the length of that. One of the problems with this particular approach here is that keys must be unique, bro. All right. So this is when we have now a hash collision. This is known as hash collision. What you're gonna do is to add this here. The question is that how you can access to that data quickly, you know, because after we sorted that elements by creating a new array, which is a great thing, okay, and then define what are the sequence, okay, in a set, all right, how can we now have access to that information, have access to the longest subsequent elements? If you have a hash as a way to count this, that's also something, there's a method for doing that as a way to count the number of occurrence, or you can have now an array, okay, where you can say, hey, you can have now an array, okay, okay, we can have now an array, all right. It's gonna simplify this a little bit, right? So once we already sort this, okay, we need is to actually count is the number of sequence. That's all we want, all right. We can have now is a counter here, a single variable, to actually count that. So instead of us overcomplicating that thing, okay, so instead of us overcomplicating that, we can have now, so anytime we're actually is checking if this is a new array, right, we can instead say, hey, so max length here is in this case 2, right, the same for this, so max length is equal 3, all right. Then you can say the max length is equal, let me actually do this, so the max length is equal to 2, right? So in this case the max length is equal to 3, right? So the max length is equal to 4 because we're iterating through all of these elements in sequence, is 4. Here the max length is not that great, but we need to find a way to count this, right? So we are quite close, by the way. So we are quite close. Let me actually take a look at the exercise here, at the solution here. We are quite close. We are quite
Let's
close.
solve how a human would, but can we actually convert this into code? So you actually look at the picture that each sequence has a start value. The start value, in this case, the start value for the first range or the first sequence has no left neighbor. The first value 1 has no left neighbor, right? That's really obvious.
Okay, so one way to do that is by that, all right. So because we're actually checking if the right element is a sequence, okay, that actually makes things a little bit harder to keep track, right? Or the left elements here. If we now look at things at different perspective, which is the left, we say, hey, is this element 1 has another element? So if this 1 has a left neighborhood, okay, or if this number actually is the beginning of a sequence, okay.
Look at the second range, 100. It doesn't have a left neighbor. The third range, 200, doesn't have a left neighbor. So we can get the start of each sequence by just looking at our entire array of numbers, right? And figuring out which numbers don't have a left neighbor. So meaning if we wanted to check if 1 had a left neighbor, we would check, does our array contain the number 0? If we wanted to know if 100 had a left neighbor, we check, does the array contain 99? The easiest way to do this and the most efficient way to do it is by taking our initial array and converting it into a set. So now to find the start ranges, let's start iterating through our array. So we get to the first.
Exactly. So if you transform that into a set, which is only unique values, which is exactly what we're doing here as a way to transform that into a from a sorted array to a sorted, right?
Element 100. Does it have a left neighbor? Well, we can check our set. It doesn't have 99 in it, so this is the first, so this is the start of a sequence. So let's get the length of the sequence. We start at 100. Now to get the length of this sequence, we want to count how many consecutive numbers come after 100. So we want to know, does 101 exist in our sequence? Looking at the number line, obviously it doesn't, but how can we check this efficiently with code? Well, we already have a set that takes up this entire array, so let's just use our set to check if 101 exists. Since it doesn't, we can no longer continue this sequence. So now we get to the next number, 4. Is 4 the start of a sequence? Let's look at our picture we drew. 4 is not the start of a sequence, and we can check this using our set. We would check that it does have a left neighbor, right? 3. So it's not the start of a sequence. We're not going to make a range from it. We get to the next number, 200. Is this the start of a sequence? Looking at our picture, yes it is, and we know that 199 does not exist in our set. So let's make this sequence. Let's try to make it as long as we can. We check, does 201 exist? No, it doesn't. We can tell that from our picture, and we would use the set to determine that. So now this is as long as we can make this set, so let's get to the next number, 1. Is 1 the start of a sequence? At our picture, we can tell 1 does not have a left neighbor, so it is the start of a sequence. Now let's check if 2 exists in our set. It does, so we can make this sequence a little bit longer. Now let's check if the next number, 3, exists in our set. Yes, it does. So let's make it even longer. Now, does 4 exist in our set? Yes, it does. Now let's check if 5 exists in our set. It doesn't, right? There is no 5, so we can't make this sequence any longer. So now let's continue through the array. 3. Is 3 the start of a sequence? No, it's not. It has a left neighbor too. Now let's try 2. Is 2 the start of a sequence? It's not, because it has a left neighbor 1. So we went through the entire array. We created all the sequences we could. The first sequence is length 1. The second sequence is also length 1. The third sequence is length 4. So this is the longest sequence. Now we took a really complicated problem, or seemingly complicated, and we broke it down so easily. All we had to do was iterate through the initial array, use a set, and check if values had left neighbors, and if they didn't, then they were the start of sequences. We made this problem so easy with only using one data structure. Since we only had to iterate through the entire...
Using only one data structure. Okay, which is exactly, so once I already have this done, okay, exactly, because the question here is that how can I access this data quickly? Because it's like, yeah, once I have this already sorted, which is a great thing, all right, how can I now is determine the sequence here?
Array, and we had to expand each range. We know that we're only going to visit each number at most twice, so our solution is very efficient. And we did have to use additional memory to create a set because we wanted to check if neighbors existed. So so for the memory complexity, it is also big O of n. In this case, n is the size of the input array. So now let's get to the code. So we remember we need to create a set from the initial array nums. So it's 0. So we want to iterate through.
We need to have a counter here as a way to check when this.
Every number in the num n minus 1 does not exist in our num set. If this number doesn't have a left neighbor, that means it's the start of a sequence. So now we want to get the length of this sequence. Initially, we can say the length is 0. And we want to keep getting each consecutive number and checking if it exists in our num set. If it does, then we can keep expanding the length. So initially, I'm going to check n plus length, because that's going to check the current number. Initially length.
Okay, this is the way of how you can actually access through that.
Is 0, so we're just checking the current number. As the length grows, we'll check more consecutive numbers. At the end, we could have potentially found the longest sequence, so we want to potentially update our longest by just taking the max of the current length we just computed as well as what the longest originally was.
If the number is not in the set, okay, because you're adding is all of this. Okay, you already have this. You are, as you iterate, you're going to add all of this. Okay, as you iterate here, you're gonna check if there is the start of the sequence. Okay, so I define the sequence here as if you have someone on the left, that is how you can define a sequence. Okay, so the thing here is that definitions. So the problem of this is about definitions. Oh my God, here we go. Oh, here we go, bro. Definitions. Holy hell. Definitions. Holy hell.
And it's really that simple. So now all we have left to do is just return what the longest the longest sequence was that we just computed. So we did this in such a small amount of code. Now let's just run it to see that it works.
Okay, that was very interesting.
Subsequent. So we want to potentially.
Okay. I'm gonna leave that. I'm gonna leave that as it is. Okay. Yeah. Because I really solved these particular problems, but it's by just following is that, but I didn't understand what he was doing. And if you don't understand what you're doing, it's like you better don't even put attention to this. Like, don't waste your time. It's like, don't waste your time. All of this sequence. Holy hell, this is a huge. This is a huge, bro. Huge. Okay. Yeah. But it's exactly, it's like you need. Okay. That's quite brilliant, bro. That's very brilliant, bro. That's very brilliant. I also see of how you can now sort an array of collections in linear time using an array, which is something that I use this technique for the top case most frequent elements. And once you already have that, okay, once you already have that element sorted, what you can do is you just only check for the next one, okay, and actually count that, So one of the things here is that with this, okay, with this, so as you iterate through the sorted array, we define a sequence as the existing of the next number. So because this collection, we need to find a way to have access to this set, okay? And that is because this already now is, so as we look at this, okay, we can now define some things here. We can now define is star sequence, star counter sequence, or define here. So define star counter sequence, all right, as a way to count out the sequence here, and the max sequence, okay, and the max sequence. So what we're gonna do here, as we iterate through this, we're gonna count is the sequence by saying, hey, is one next to another, is this first element and the second element is next to each other. So how can we do that? So define start and sequence and the max sequence, all right? So here I'm gonna do this, define star sequence and max sequence, all right? So by now having these elements already sorted, okay, we can is do this. Okay, so iterate through the sorted array. We define a sequence as the existing of the next number, which means is as we iterate through, we're gonna check if the next element actually is +1. Okay, so check check if the next element in the ith position is +1. Okay, is the num, okay, is the nums at that position +1, right? So if it is, star counter, so update star sequence counter, all right? Exactly, if it is a star sequence counter, all right, and check if check the max number between star sequence counter and the max. Okay, check and update the max sequence, right? However, if it's not, okay, if it's not, okay, if not, then what you want to do is, well, let's go into now star the sequence. So start or set star sequence to 0. So start to count the new sequence, right? Exactly, start to count the new sequence, and you're gonna do this over and over and over and over, and then exactly. If it's not, start a sequence. So we can now actually write the code. So we are quite pretty straightforward, because at the end of the day, it's like once you do that, once you update the start sequence, if it is the next element, okay. And if it's not, set the start sequence to 0. All right. And then return. So after iterating through the sorted array, return the max sequence length. No, max sequence length. Okay, makes sense. So now we can write our code here. Okay, so we got is this. I just want us to get rid of this, right? Okie dokie, as well as this and this. All right. That's this. You got to my name. Define start sequence counter. Okay, so first thing first, let's go to sort this, right? So we got this now, the sorted nums by saying is the by iterating, okay, to the nums, and return me a new collection that satisfy this condition, right? And in this case, I want you to now have this sorted nums as an array, followed by the update start sequence, which is this. So counts start sequence equal to 0, and then you hey counts max sequence length equal to 0. So first thing first, I want to now iterate through that and get this sorted array in linear time. Let's get into this. So what we're gonna do is to say, hey, because you have now the num and the index, right? I want you to now is to sort this. So what is the value of this num? Okay, I want you to now is at the position sort nums, right? At the position of the num, all right. I want you to now add that num, right? And if you have any values that are already there, I want you to update them. So we fix the duplication problem. So far, so good. Pretty straightforward. Pretty straightforward this one, right? So that's good. That's great. That's awesome. We can actually console the log to actually check that actually do what it's supposed to. In fact, because we are here on NeetCode, we can say is that return. I know it will fail, all right? But I just want us to get this, right? So run this, okay? And we're gonna get at least, it's not assignable to a num, right? What the French toast? Sorted nums, the index num is equal to the num. What the French toast? Can you not inherit that? Type any is not assignable to type number. Really? Number array. What about now? So now TypeScript is complaining about that. And wait a single moment. Type number array is not able to type number. So we get the element, right? The number here, followed by the index. Exactly. So we want to now at that position, okay, is store that number. Right? Sorted num. Oh. Okay, I get it. Yeah. Yeah, TypeScript being our sidekick here. You say, hey, it's not a value, expected return. What is this? 104, 200. No, why can't I? Oh my god. Okay. Max sequence, which is 0. Okay, but I want these two is console log this, right? So to show that we are not that crazy. Exactly. But the nums is 104, 200, 132. And then you got this, right? You got an empty slot, 1, 2, 3, 4, 195 empty items. And then 100, right? And there's no 200. What is it? 200. Okay, 99 empty items and 200s, right? So if you want to know what is the length of this, I will assume that the length of this is now 1, 2, 3, 4, 5, 6, right? If I am not crazy, that's what it is. Interesting. The length here is 201. Oh, that's not good. That's not good. That's not good. Again, the constraint here is in terms of time, not in memory. So the constraint here is in time, not in memory. Okay. So yeah, we have 200 elements. Makes sense. Because what it's doing exactly when you assign to this is now JavaScript behind the scenes assign dynamically this huge amount of space slots here that you are adding all of these elements here. So we already got is this sorted element, right? The way we want to. So far so good, no problem. So now what we can do is to flat that and to get only those elements that we need to. So by flat is that I want you to now is only get me is the values exactly out of this. So what we're doing here is that now I want you to get me the values out of this. Okay. So here by doing this, because now we got us our sorted array. Okay. And here we're saying is remove empty slot. We are actually iterating through that. So iterate through our array and remove to remove empty slots, which is great. All right, cool. So okay. So all right. Now because we already have this sequence, so we can say is this. All right, let's go to iterate through that sorted num using for each, because I don't want to actually generate is I can use this for each as well instead of actually using that. Or we can also use another terminology here, which is for of nums, okay, I want to now get is the num and do this, which is pretty much this one, right? It's like, hey, I want you to know is, for real? Okay, we're gonna play games. Sorted nums of that num, and I want to assign the num. Pretty straightforward. Much more succinct, clear, as you can see, than the other one. So yeah, you buy me. Then you want to flat that, all right? And here is when we're gonna say, okay, let's go to now iterate through this element, which is for const the num of sorted numbers, okay? Where the whole point of this is to check if the next element actually is +1, which is this one. You say, hey, if the next element, if the element's at that position, because we want us to get into the entries, so I want to get this now the index and value, which is the index and value, in this case num, okay? So if the number in if the number in the next position, okay, so check if the next element in the position again is +1. So hey, I want you to now check if the sorted nums at the what is the value of the next position at the start of the sequence, okay? If that is the num +1, okay? So what we can do this to get is this by saying is, hey, I want you to now assign a variable here to be more explicit and say hey, is this element, this sorted index +1? So next element or next number, which is this one, okay? Next numbers, and this is to check if this is a sequence, okay? We can say num. So this is the next number, and we want to check if this current next number array and next number, right? So you can say this next number, say next number here, and then you do is this by saying, you know what, it's gonna do this. Hey, this is the next number, okay? Next number sequence, okay? Next number sequence and next number array. Hey, if the next number sequence is equal of the next number array, okay, or next number array. So if this number is the next number sequence is the same as the next number array in terms of value, if it is, we are now in the presence of update the star sequence counter. So here we're gonna do is this. Start sequence, because this must be a variable, we're gonna update this. So here we're starting the sequence here by saying, hey, what is the max value here between the exactly, we're gonna start the sequence here, okay, by doing is this. Hey, start the sequence, okay, and check the update maxing between the start sequence and the max. So you're gonna do is this. Hey, let's go to actually is give me is the sequence length. So we're gonna update the sequence length here with the nice, very convenient math object, math API from the browser. Thanks for that. To do this, it's like, hey, what is the max number between the start sequence and the max sequence? Okay, length. If it's not, all right, then set the start sequence as 0, right? Right, then start sequence. So put start sequence here as 0. And that'll be all. Okay, and that'll be all. It tells me this one. Output 3, expected 4, because we're starting to count from 0. That's what happened. Okay, we're starting to count from 0. Exactly. And then it gives you is the wrong case. This is quite interesting. Output 3 and expected 4. Max sequence length is this one. It's a way to update that. Okay. Yeah, but it's because we're starting to counting is from, we need to count this from 1. Yeah. Oh, it's start a sequence from 1. That's what happened. Exactly. Start a sequence from 1. Okay. Makes a lot of sense. And there you go. So if we want to test now this code, we submit this. Hopefully this is supposed to work as expected. And then you got a wrong answer here, which is now handling is edge cases. All right. Okay. Expected 0, we get is 1. Okay. So if nums length is equal to 0, we can just return is 0. That's quite interesting. We submit this. All right. Oh, interesting. Now we are handling is okay. So now we're handling is interesting. So now we're handling is negative values. Oh, okay. This is a very interesting thing here. This is a very interesting thing here. A very, very interesting thing here. This one. Okay. And then we want to iterate through this. All right. And then create this. That's right. And then we want to now console log the sorted nums. It's because now arrays, okay. Oh, that's interesting. Exactly. We are counting is now positive numbers, no negative numbers. So okay. That's quite interesting. That's quite interesting. That's very, very interesting. Okay. At least for positive number, it works. Okay. But because the way how now we are actually, this is interesting. If we want to say array -2, array is not defined. It's going to say, hey, counts new array, and then I define is now this one, and then right below I want to say, hey, new array at the position -2, it'll be equal to -2. So if we take a look now at new array here, it's okay. Array doesn't work with negative numbers. Okay. These solutions work for positive numbers, not for negative one. Makes sense. Okay. All right. That makes sense. Okay. No problem. So that'll be all for this video. Take care. Bye-bye.